Thanks, Angus.
Thank you, Andy. Yep, so recapping last week, we looked at this pattern of these sort of primarily two fire resources, but three in this diagram. So task is a fire resource, service request is, and organization. And then we talked about this pattern where the service request is almost the immutable information about what is being requested, what exams or tests are being requested, who's requesting it, what time it was requested. And then task is a resource that controls the workflow about who's going to do this service request, who's it directed to or not, what status is it up to, is it in progress or not, and just
are you supposed to be? Are you trying to show something, Angus?
I am
We don't see the
showing
screen.
something. Sorry.
It's all good.
How about that?
Yes.
Purple diagram. Yes. Sorry. So yes, these three resources. So task controls the workflow, service request is the actual information about the service request, and organization being the owner of the task. So that might be a pathology lab or a diagnostic imaging clinic so we covered that. And then because we order more than one exam, typically in pathology, it's usually about 3, radiology, maybe it's 1, but could be more. Therefore, there's multiple in any one request that we do in Australia, like a request form, there'd be multiple sets of these. So it would look somewhat like this, where you have a task and a service request for each exam or test being ordered. So full blood count, liver function tests, monospot would be these 3 pink boxes. Each would have its own task. And then we have this concept that groups those into a request group on the right, and then a task associated with that risk group. So there's a nice sort of synergy going on here that every ordered item has a task, and the group of tasks also has a task. And then, of course, an organization that owns those tasks is eventually assigned. So that was kind of what we talked about last week. That diagram is in the draft profile we have, is this same diagram here. So regress group has regress tasks, and many service requests have tasks. It's the same diagram, but flipped around the other way and in white. So that's what we covered a lot of yesterday. This week, what we really want to start looking at is the workflow that we can do with tasks. So we're really looking into the workflow parts of fire, just so that you can navigate here to understand where it is. I'm on release 4. If I go to home, if you go to documentation, down here you've got fire workflows, and that's really everything we talk about today will be in here. So we click in here.
We can't see that, Angus.
Can't see that. Must have shared the. And now?
Yes.
Yes. So just to repeat that, if I go to home, documentation up here, fire workflow, this is everything we're going to talk about today is in here. So I click in here. I'll just point out these tabs here. So there's more than just the overview. There's information under these tabs, which we're going to be going through. So I personally find I always struggle to find these because I forget about these tabs. So we're going to talk about fire workflow. So fire has particular resources to deal with workflow. It actually categorizes resources, and I'm going to move down to this section here. All the resources in fire, or many of them, get categorized into these 3 sort of categories: request types of resources, event types of resources, and definitional types of resources. If I scroll up to just here, that is those sets, the definitional ones, requests, and events. So I'll start with what we know. So our service request, the resource where you'll order a test or an exam, is a request type of resource. And task, which we're going to look at heavily today, is an event type resource. This third type, definition type resources, we're not going to cover today, and probably not for R1, but it's more about defining what might happen in something like a care plan. Like in this care plan, we're going to order these service requests, we're going to create these tasks. It's more about workflow at a, not a sort of a high level, but at a sort of granular level, like this care plan requires these tests to be done. So I don't know if we will be delving into this world in R1, but certainly requests and events we will. They gel together. So building on top of the work we do, people could start defining care plans that synergize with the work we're doing. So that's those three resources. So there's common properties that all request resources have a set of common properties, the same with events and definitions. So I just wanted to highlight that. And then I'll move into communication patterns. And what we're really going to talk about today, and I'll just take a sneak peek at it, is these sorts of patterns. We're talking about, we know we're going to use a service request. We know we're going to use a task resource, but how are we going to use them? You know, do systems just post them to some server and hope something happens? Do labs, you know, what do? Do they just start scanning repositories to find new requests? It's the workflow. Like, how do these systems, how are they going to operate together? So if I go back to communication patterns, so I just want to read through these sets here. So as described previously, so these are considerations that FHIR's highlighting for us to start thinking about when we define workflow. Remember, these sessions here are about just trying to educate us all on what FHIR has. In the coming sessions, over the coming months, we're going to go through the minutiae of this and choose patterns, talk about patterns. But at the moment, we're really just trying to educate. This is what FHIR offers us. So I'm not purporting, you know, we're going to do this or anything. I'm just trying to walk us through what FHIR provides us to make these decisions. So when thinking about workflow in FHIR, you know, there's these core points they say to think about. So is sharing of state of the workflow necessary among the participants? So in our context, places, so doctors placing orders, labs and radiology clinics who want to do those orders, are we going to share state between ourselves? I'd presume we're going to share state in the sense of the statuses of the order. You know, is it collected? That's a piece of state that the lab has to share with the requester. The requester wants to know about it. The requester has to share the actual order. So is state sharing, is the sharing of state part of your workflow? Which paradigm do you want to use? REST, messaging, services, a mix. So FHIR has these separate paradigms. It heavily revolves around REST, like gets and posts of resources into FHIR servers, but it also has a messaging paradigm, which kind of mimics something like we do in HL7 version 2. You can just build sort of ad hoc services that are really just, you know, post a resource here, and this service will do some custom operation that achieves some goal. Or you can use a mix of all these realities. So we need to consider that. Who owns, manages the various resources involved in the workflow? So when we talk about service request, who's going to create that service request? Is it the placer, the filler, someone else? You know, obviously I'd like to think that the placer, the doctor requesting, the system that the doctor's requesting in, they somewhat own the service request because it's the doctor who creates it. But do they own the task? You know, does anyone own the task? Is it shared between them? So just thinking about who owns or manages is probably more the key word, each resource. Is there infrastructure in place to support polling, push notifications via subscriptions, or both? So FHIR has a subscription architecture built into it. You know, so when a resource is put into a FHIR server, other systems can register subscriptions in that FHIR server that says, when a resource appears with this criteria, I want a ping or something being sent to me to make me aware of that. FHIR has that built in. So, you know, in our process of orders, you know, I think it's going to be a critical component. You know, labs are going to want to know when there is a new order. Possibly eventually when reports come back, the placer of the report wants to know when the report is produced. So this notifying each other that an event has happened. Is there a need for confirmation that a desired performer agrees to act, or can that be presumed? So this touches a lot on our use cases, that if an order is created, we want some lab or some radiology department to take ownership to do it. Is there a need to confirm the desire to perform, agree, or act? So I think as we move forward, we are going to want that. We're going to want our order to our fillers to inform us that I'm going to do that. Not just leave it hanging out there, which I guess is something that V2 is not so great at. What we do today, we sort of just throw orders at labs, and they acknowledge that they got the order, but did they agree to do it? Can they reject it? Things like that. Is there a need to negotiate how the request action will be performed? So this is sort of like a state machine. Negotiating, you've sent me your request, I'm working out whether I can do it. I'm then maybe rejecting that request, saying I can't do it. So negotiating, the request, rather than just as V2, rather than just throwing at them and just hoping something happens. Can the requesting and performing system communicate directly? Are they able to post to each other's servers using REST? I'd add something to this one, which they mention here about a queue server, is in a very closed system, maybe in a hospital, you might say the requesting and the performing systems communicate directly to each other. Within the hospital, the EMR talks to the lab system directly. I think the scope we're looking for here is far wider than that. We're talking about N order places, all the order places systems being able to place orders that N providers are going to act upon. Many pathology providers, many radiology providers. So can they communicate with each other's systems directly? It's a question we can ask. Or is there going to be a central order repository or a federated set of central order repositories? Which leads to, is there the need to have a queue server to facilitate workflow execution? They use this word queue server all through the standard. That's kind of their way of saying a third-party server. There's the placer, there's pathology or radiology, but there being a queue server or some server in the middle that we all communicate around. How many potential actors are involved? I think we know that's many. It's more than two. So there's not just a placer and a filler. There's going to be many places, many fillers in our use case. Will the workflow always be directed? Is there a pool of potential performers who could choose to perform the requested action? So this comes to our high-level 3 use cases we've been discussing. We're going to have, forgotten the term we're going to use, but allocated requests that are set to go to this provider, requests that are redirected, they were set to go to a provider, but they're now, the patient chooses to go elsewhere, and the possibility of unallocated requests. So that's to this point about directed. So that's just a sort of prelude to sort of things we need to start thinking about in choosing the workflow that we're going to use.
Because we've just got some questions. I know Andy's responding to them, but the most recent ones, how would a hybrid workflow work? And I think that would, in terms of a paper request or a manual one and an eRequest.
Yep. So
I'm not expecting an answer, but I'm just sort of, this is some of the questions coming through. Yeah.
Absolutely good question. Where a lot of what we're focusing on here is the electronic part of it, but of course we need to consider, none of that electronic stuff happening, a paper request. So I guess FHIR is not going to give us a lot of advice about how paper requests work. It's kind of, I think that's an element we have to bring in, but I don't think the FHIR electronic part of it is going to really address that for us, but we certainly do need to address that. So we touched on this last week. This is the state machine they offer if using tasks. We talked a lot about this last week. I won't go into it. We may touch on it at the end. I did just want to get to this example workflow state as a very baby step into what we're going to delve a bit deeper into in the next couple of minutes. So So the following table shows steps for a simple blood test order and the corresponding values of the task attribute. A lot of the details and attributes have been omitted in order to focus on the state changes. So this is a very, very basic description of what might happen. Provider orders a blood test for a patient A, service request resource is created to represent the order, a task resource is created to represent the request for the lab. The task based on points to the service request instance. So there's our two resources being created when the order is placed. The task status is requested. The task status reason is it's a new order. The business status is ordered. Remember, these are lockdown statuses by FHIR. These are open for our interpretation. We might say collected, in lab, or arrived, or image acquisition. We can change this as we see fit. But these ones directly relate to that state machine there and are not changeable. So a lab accepts the order. So the task status moves to accepted. The task reason moves to able to perform tests. The business status is accepted. The patient is at the lab. The blood is drawn. It's in progress. Obtain the specimens made available. Work on the blood sample is in progress. Preliminary results are available. The diagnostic report resource is created, and the output task.output value references the diagnostic report. The task moves to in progress or stays in progress. Preliminary results are available. Preliminary results available. And finally, the final results are available. The task is completed. The status is final results are available. The business status results, final results. So that's a very skim over the top, just simple basic of where we're heading without all the detail. I won't go through the other examples. They're not quite as relevant, but you can look at these as well. And what I want to get into now is these lists of patterns. So if I go right back to the top of this page, we have this ad hoc workflow patterns and workflow management patterns. The difference between these two is this one does not use task and this one does. So I am going to start in the ad hoc one. And just, I think I'll focus on this diagram because I think the diagram's a bit easier to walk through and rather than just talking words at you that are written all the time. So this is, again, really simple, starting at baby steps. It does not use task. It kind of is very similar to what we do with HL7 version 2 messaging today. The placer posts the request to the filler. So he's sending them a request resource, such as the service request, straight to the lab, so straight to the filler. The filler's acting accordingly, doing something for that request, and then he's posting an event resource back, i.e. the diagnostic report. And then the placer who gave the request to the lab is then updating the request at the lab saying request completed. So almost the bare bones simplest thing you could do. And really what we do with HL7 version 2 messaging, we send a message to the lab does some work, the lab sends a report back, and unlike V2 messages, the doctor then updates the lab to say, you've done my work, thank you very much. I'm not proposing we do this, but I'm just baby steps walking up the complexity. And that's probably the most simplest thing you could do. But what's worth noting is the limitations of what this has. So, it has benefits of lowest amount of overhead, no need to use the task resource, no need for polling or subscriptions, explicit acknowledgement that the filler has received the request. Limitations can only be used when the requesting fulfillment can't use to request status changes or other updates. So there's no status updates going back here. It's you just send it to them, hope they do something, hope you get a result back. So no status updates. Placer and filler must be able to communicate directly with each other. So in this case, it's a direct connection between the doctor's system and the lab. Must each have a FHIR server and must have write permissions to each other's server. This could become unmanageable if there's large or dynamic number of places and fillers that need to communicate, which I'd argue is very much our scope, is that. No indication of agreement to act on the request. So as you see, you just sent it to them and hope they do something. Hope you get a report back. There's no ability to negotiate fulfillment. So there's no ability for the lab to say no, or the radiology clinic to say no. Just, they just take the request and people hope it happens. It completely reverses the use of provenance resources, as the request only exists in the fulfiller system and the events only exist on the placer systems. I don't want to go too far into this. This is about provenance, is about other resources that talk about the history of where did resources originate from, who updated them, and whatnot. So they're just trying to say that provenance now is kind of spread across the two. The only way to stop fulfillment is to update the request to have status of cancelled. So there are limitations of that. So this is another variant of that. I won't go into this in depth, but it's another approach without using a task. So the placer creates a request, puts it in their own system. The lab is polling or has a subscription that it tells them when the request's been placed in their system. So they poll, they work out the request exists, they act accordingly, they create an event, which would be the report, and then the placer system, the doctor's system, is then polling for new reports. So that's another way. And the ERS don't have diagrams, but you can read through them, but they're all simple without task. I personally think, they're probably no better than the ordering we do today. They're going to struggle to do the whole industry trying to order. I would use these patterns if I was just going to replace the current ordering we do with a Fire version of it, and we don't get really any benefits. It's a very messaging sort of approach. So I'll move to workflow management patterns. So still the same topic, but what's been introduced now is task. So you can see this task involved here. This option F is one that we're keenly looking at. It's actually pretty much what Genie and Sonic have done with their implementation today. And I think it's a high candidate for use, but there are others down here that could also be candidates. So I'll walk through this one. The other thing I'll say is they don't have a queue server here, so there is literally a places server and a fillers server. I think it's highly like that's possible, but I think it's highly likely there would be a third party, like one in the middle, but it kind of acts as the placer. So doctor place an order. The system creates a request into the places server, the service request. The doctor's system also creates a task associated with that request. So the service request and tasks are both living in here. The filler system, the lab or the diagnostic imaging clinic, they've pre-registered a subscription with this service to say, tell me about any new tasks for my organization. So when that's committed here, they get a poll, they either poll or they get a notification. So they become aware that there is a new order to be actioned. They go and get the task resource from it because it's living over there. They put a claim on the task. So they update that task to update the statuses to say accepted, or basically I'm going to do this, I'm willing to do this, or they might reject it for some reason. They act accordingly, so they do their work. It goes, samples are collected, patients arrive at clinics, and they update the task as that is occurring. This is grey to say this can happen many times. So they've claimed the task, and now they're updating the status to say doing this, doing that, doing the next thing. Like collected, in lab, complete, or arrived, image acquisition, report typed or something. Status is going update. Eventually, they create an event for themselves, which is the report, and they update the task as completed. The places system, the doctor's system, then in reverse gets the event about the report, and they update their request as completed in their system. So it has benefits and limitations. So uses the REST API for managing workflow. Both placer and filler can track the state of the workflow. Can use this approach for requests other than fulfillment, e.g. to request status changes or other updates. There's an ability to negotiate fulfillment. There's the ability to say no. So the systems are now having a two-way conversation. They're asking each other, can you do this? Yes, I can do that. Explicit acknowledgements that the filler has received and agreed to act on the request. So that's that two-way conversation happening. Supports cancellation through ability for placer to change the status of the task to cancel. Has some limitations though, so additional complexity of task. So it's a bit more complex than not having a task. Additional complexity of setting up and maintaining subscriptions for polling infrastructure. So this polling stuff, you need a file server or something that can do subscriptions for you. All the commercial file servers can do subscriptions, so it's not too bad, but it is extra complexity. Placer and fulfillers must have a file server, and placer's file server must allow write and update to the task resource. So I'd call this out as not entirely true. It is if this is what you're doing, but if you're going to have a queue server, if you're going to have like, I don't know, a government run server in the middle or a server that everyone's talking to, then this isn't really the true. Like the placer and filler must have a file server and the placer and file server must allow write access. If you think about this pattern with the middleman, then everyone needs read-write access to the middleman, but not to each other. We all communicate through the middleman in the middle.
Hey, Angus.
Mhm.
David's got a question.
Yep, go David.
Me,
Okay.
David Willock, say.
Hi, David.
Yeah, Angus, I did have a quick question.
Oh, sorry. I was on
Oh,
mute.
sorry. No, David. I didn't know which David they were talking about. You go right ahead. I have got a question, but after you.
I was just saying I'm a really big fan of this option because I think it's scalable to the size that we need, and the subscription notification capabilities create a really modern, flexible, scalable architecture. I just want to test it with one scenario. So imagine we've got the Genie system as the placer, the Sonic, but we've got not the Sonic system as the filler, but a filler that's never worked with Genie, and a patient comes along with a paper order with a barcode. How do we start that loop? How do we get the filler connected with the placer? What's the mechanism in there?
Yeah, this workflow is not, describing us how to solve that solution. We certainly, it's our scope to solve that problem.
Cool.
And it comes down to this step 3 poll notification in my view. So in my view, the request still gets created, and so I see this as being a central repository or some federated set of central servers. So the doctor still creates their request. A task may or may not be created, and then there's going to be this action that happens before poll notification, which is allocation of that task to someone. It's either pre-allocated, right? So the scenario where the doctor has chosen a lab up front, so immediately the task has an allocated owner to it, so the poll goes straight to that person. But in the case where it does not, it's sitting here, and then I would sort of see a bubble off the side here, which is the patient has arrived at a diagnostic imaging clinic or a pathology collection center, any one of them, and they scan a barcode, and they're calling back to this server saying, I have the barcode for this task, and I am Sonic Healthcare or Helios or whoever I am. I would like to claim that task. And that action would then update this task to say, okay, it is now claimed by you, the person who just scanned the barcode, updates the task, and then this poll notification happens. Like, because it's now associated to someone, the lab, so Sonic here now gets notified, or at least in the action of assigning the task for them, they get the information allowing them to get the task. Yep. This 3A.
So we've got to make sure that the endpoints are also inherent in the encapsulated in that QR code, or yep.
Yes, yes, and that's an issue. It's a big issue we have is how do we service discover? Is there a central service that we all know that's the central service? Do barcodes have the full URL in them that takes you to one of a federated set of servers? Is there a side lookup service where you say, I have this barcode, can you tell me which server does this live in? Oh, it's in this server. Thank you very much. I go to that server. all issues we have to solve. Sorry, was there another
Heath?
question? David Wilcock. Yeah.
I was just going to comment on that one as well. Keeping in mind this option here is probably thinking about it more from an assigned filler perspective, and hence the task is effectively the assignment, and we know who to send the poll notification to as a result of that. In an unassigned scenario, or in a reassignment scenario, that organization that you're talking about would be doing a query, but that would be perhaps based on some token that's on a phone, QR code, that kind of thing. And you're right, we would need to have some way to resolve the actual endpoint in that QR code, whether that is a direct URL or some sort of indirection of the URL, to be able to query the actual service request itself, in order to then create their own token. Never known Genie before. We obviously have an authorization issue as well. So, whole nother topic that we need to be considering around is our authorization capabilities. So Smart on Fire, whether national certificates have a role, all those sorts of things. So when it comes to never had any kind of relationship before, you need to have some sort of relationship. You need some sort of mechanism just to get past the security aspect. You don't want just any randos coming in and claiming these things.
David Willock, did you have a question?
It was just about the choice thing, Andy, to be honest with you. And I think I was confused. I didn't know whether that was in step 4 or in step 2, whether it was in the put claim or, and this is to do with unassigned, I think.
Yeah, I think to me, it's pre-3, that so a request is created for an order, a task is created for it, and it's just floating in here unassigned to anyone.
Right.
And then when the barcode is presented at one of the providers, diagnostic providers, they'd be calling onto this saying, I've got the barcode for this task, I want it assigned to me. And that service would do that for them. And then 3 would occur, or 3A would occur.
Thanks, Angus. Yeah,
I'd call out this too, just because we were talking about. So the fulfiller system uses either polling or pub sub to become aware of the existence of the task, which is what we're talking about, right? A common case may be the conveyance of the task ID to the fulfiller, the lab, by other means. For example, a lab test is ordered and the patient takes a requisition to the lab of his choice. The requisition contains the task ID, like the barcode, as the barcode, or stored in the patient's healthcare smart card, which I thought was interesting. You could use via smart health cards to do this. And the lab system can execute a direct get for the task, thus eliminating the need for a subscription and polling. So that is their, that's their comment on what we just talked about. I've got some issues a little bit with that. I don't know if we'd use the task ID, but the premise is the same. Is there any more questions?
No hands.
No hands. Okay, so I think we were just talking about benefits and limitations. So limitations, complexity of task, setting up the maintaining subscriptions, the face may communicate directly. This could be unmanageable. So again, they're saying it's unmanageable, but I think this is where we start talking about what they say a queue server. So might not apply if there's a queue server. So I think this could be unmanageable. The place of fulfiller must know where to subscribe, which is all to this point. I think they disappear when we start talking about a queue server, a central server or a set of federated servers in the middle nullifies those 2 points. Does not give the fulfiller control over whether the task can be cancelled. I'm not sure where they're getting at there. Like certainly in the state machine, the fulfiller can reject a task, which is kind of them cancelling it from their direction. The placer can cancel it, but the lab can reject and say, or a diagnostic imaging clinic can reject it and say, I'm not doing that, or I can't do that because I rang the patient and they're not willing to do it, or whatever the reason is. So it's not true that they can't cancel it. They can reject it, which is kind of the same thing. Use recommendations when following the state of the workflow. When following the state of the workflow is important. So yeah, so it's recommended when following the state is important, and I think that is for us. We want to track state of our order. When there is a need to know that the fulfiller has accepted to perform the request, when there's a need to be able to change the performance of the request. There's a need to be able to change the performance of it. I think they mean the performer.
It's like, yeah, well, changing fulfillment.
Yeah, changing from one lab to another, which is something we want when there are multiple steps in fulfillment. So it's not just, yeah, I'll do it, and originally back to your statuses. When the requests are not always directed to a specific filler, which is to the point we just talked about, when the placer needs to manage task resource. So this is I think this is a high candidate for what we're looking for. We're at 20 minutes. So I'll go through this one as just another one. It's kind of similar, but I don't know if it suits our use case. So here the placer creates their service request and puts it into their Fire server. And then the placer system, or the system that gets the service request, it is sending the task to the lab, to the fulfiller, as opposed to just the task sitting here and the lab's polling or getting subscriptions about it. Now the task is directly sent to the lab. We could do that. It's another approach. And then now that the lab has received the task, the lab then calls to get the service request. Then they update the task as accepted. So they then update their own task to say accepted. And the placer system, the doctor system, is now the one that's doing the subscription or the polling of the lab system to say, have you accepted my task? So it's kind of flipped the roles around the other way. We're now saying, oh, the task lives at the lab side or the diagnostic imaging side, not the repository side. They act accordingly. They update the tasks in their own system. Meanwhile, they're getting poll notifications about those updates. They create an event, such as a report. They update the task as complete. This guy works out it's complete because he's doing polling or notifications. And then he comes and gets the diagnostic report. So it's similar to the first one, but you've kind of flipped the roles around the other way. It's a candidate. It's not. I prefer the other one, but it is an option. And it's the last one I'll do. So this one's different again. This one kind of has a broker in the middle. It's not the placer or the filler, which is sort of what we're angling towards, but let's walk through what they do. So the placer, the doctor's system, placer requests into this sort of central Fire server broker. It receives just the request. Notice they're not putting the task in here, they're just putting the request in. This system realizes the task has been placed and it generates and posts a task resource into itself for that service request. The fulfiller, say the lab, then gets a notification that a task has been created for it. It then updates the task to say I'm claiming the task. It acts accordingly, does the work through the lab, updates the task, say, in lab, collected, arrived, scheduled, whatever. And then it posts an event like a diagnostic report into the broker. And then it updates the task in the broker to say completed. And then a poll notification of the task completed occurs, which is sent all the way back to the initial doctor system to say your order is complete. So it's another approach we could look at.
Paul's got a question.
Yeah, thanks, Andy. I just want to double check that I understand this right. So in this scenario, the place is actually putting a request in and then it's the workflow broker that's creating an associated task.
Yes, that's how I see it.
Yeah,
just putting the request and post the task. It's supposed to create here by itself.
Yep. So that's business logic the workflow broker would have to implement to
Yes.
Yeah, that's a bit vague, I guess.
Yeah, it is. It's indicating, although it's not very clear, it's kind of
Yeah.
saying, and custom action happens here. Like
Yeah.
This one we did, the first one we looked at, there's no outside the fire functionality existing. Like it's just using everything you get out of a commercial fire server.
Yep.
This one's starting to say, oh no, there's sort of magic happens here. Like, your fire server needs some custom operation so that when
Yep.
a request is entered, it's going to create a task.
Yeah, so there's a whole heap of business logic, of business rules that are actually being applied to create those tasks.
Yeah. To be fair, even this one we first looked at, as the discussion that David Heathcock brought up about, you scan the barcode and the task gets allocated. Well, that's a custom operation too, and I don't think we can avoid that. Maybe we can. This notion that you claim it, I suspect, is going to be a custom operation somehow, because I'm not sure. But
the claiming isn't fulfilling a task, though. It's just claiming that task.
Well, something has to happen when someone scans a barcode and you call an endpoint and say, I want this. Something has to then update that task to claim it. Now, we can't let's say, I'll use Sonic as an example. Let's say I scan a barcode, it's a Helios one. I need to call a service that I don't control, right? I just say, I have this barcode. Please assign the request to me. If we said, no, let's make it agnostic to a custom operation, now Sonic can just claim tasks at free will, and I think that's going to be an issue, that we can't have providers just having unfettered access to just claim whatever they want without a token.
Well, then they can set themselves up as a broker for disseminating to others as well, potentially, of those. Yeah. Okay.
I'm just trying to be fair and point out that even though we're sort of eyeballing this and saying, hey, that's a custom operation, so I suspect there's going to be one anyway.
So in your current implementation then, Andy, Angus, you're taking responsibility, Andy, for creating that task associated with the service request on your side. So you've got business logic in there, Andy, to actually create that task that goes with the service request now?
Yeah, currently when there are three kind of roles here. There's the placer, service management, and the filler. So at the moment, for a directed request, we would create that task owned by the directed fulfillment party. In the case of an undirected request, the request would sit there waiting for someone to claim responsibility based on the barcode. They claim responsibility. That claiming doesn't really need to be done by the placer themselves. It's done by the service provider, and they then make sure that a fulfillment task is created, assigned to the requested fulfillment party.
Yeah, that makes sense. And to your point, Angus, you always actually are going to have that sort of that business logic in place to create the right tasks for the service requests at some layer.
I think so. And look, it's really just like a little service that sits on the side that you call and it interacts. It has admin access to interact with the tasks in the repository.
What we're looking at is an operation potentially that will encapsulate that logic and have expected inputs and outputs, obviously. And this is the sort of thing that US Argonaut in particular have done around scheduling. They've created various operations over and above so that you're not having to do the business logic as such and do everything in a REST kind of way, because it's going to end up being a transaction of things that need to be done. Like multiple resources will be affected potentially.
Makes sense. Cool. Thank you.
So we walked through that one. I don't think I'll go further, but
Daniel's got a question.
Yep, Daniel.
Oh yeah, just it's more of a comment than a question, but I just noticed that the broker-based scenario also doesn't require the placer or the filler to actually have a fire server, which might be a valuable consideration in terms of transitional issues, whilst many of the GP systems and such like are not fire-based. So just drawing a point out of that. So
Yep, it's a good point. Yeah, they're just acting as a client here, and the filler is getting notifications. They're acting as a client. Yeah, true.
This is really the intermediary solution, basically.
Yeah, it's a good bridging point. Yeah.
Notice option G is gone.
Ah.
We've skipped from F to
no,
H.
G. We walked through G.
Oh, did you? Sorry,
yep.
I wasn't paying attention. Thank you.
No, we walked through G. G is very similar to F. It's kind of just the roles are flipped. The task lives on the lab side as opposed to the GP system side or the central server side. So
yeah. So for history's sake, these are the two that I guess Jeannie and Sonic debated for a while.
Yes.
And it was really came down to who we thought had responsibility for the service request versus the task.
Yeah, a lot of this does come back to data governance, and that's a discussion in Fire that maybe isn't there in version 2, which is if you're exposing data to a community to discover and use with appropriate rights, then is it better to keep data that you create and manage within a system that you look after? The alternative is to put it into a third party, or do you put it at the party that's going to make use of it? The problem with putting it the party that wants to make use of it is you then have an ongoing obligation to ensure that that data is up to date. Whereas if you keep a copy local, which you manage and look after, others can come and get that from the source of truth as needed. And that is a much richer data sharing, data governance infrastructure than maybe where we've come from before. So in terms of these service requests and tasks, the argument was that the request itself belongs to the placer, and therefore that should be in a place of their choosing. And one could argue that the fulfillment task can be, I think it's a bigger argument about whether it stays at the placer or the filler. But it becomes more complicated with rights associated with the creation of new resources within fire servers and an ability of organizations to put up a functioning fire server to meet their part of the workflow obligation.
I just want to move on because of time. So I'm not going to go through this. There's one more here that has a diagram. There are some more down here that don't have diagrams that are explained. So I encourage people, there's one other there. I encourage people to look at these. So by all means, have a look at these, but I won't go through them now. They're probably a bit more complex, but should be considered, if you're digging into this. I now want to switch to just looking at task again, the task resource. This is we're trying to just get move along with understanding this coming up to our clinical days, and we're going to walk through service requests in the next couple. So we're going to try and work through task here. And I just want to walk through these properties and just sort of describe each as what do we get on a task? What does it hold? So a task can have an identifier. Not quite sure what that would be. You might think the barcode, but I think it's going to go here. But you can put an identifier, a number of identifiers on a task, just to identify it. These two here, instantiates canonical, instantiates URI, they're really about definitional resources. They're about pointing to a definition that describes what this task is or how it's to be performed. I think it's a bit down the road for us to be looking into that space, but it's there. Based on, interestingly, in the Genie Fire one, we didn't set this, but I did note in the content I just read out earlier that they had, in the first example, they talked about setting the service request to this. So based on the service request, we actually had set focus to the service request, what task is acting on the service request. But I can see conjecture in the examples, they're setting service request here. So based on, it says you refer to a higher level authorization that triggered the creation of the task. I personally think based on is more like a care plan. This task, we ordered this service request based on this care plan, something like that. Group identifier. So this is, I think, very key. This is where we believe the barcode would live because it's a group identifier. It's a barcode that exists for all the tasks and all the service requests. It's the grouper of everything. So I suspect our barcode will go in here as an identifier. Part of is where you can chain tasks together. So we looked at that diagram, this diagram, and see we have a group task with sub-child tasks. So this part of would point to the parent group task. Status is this status of the task that closely follows this state machine we've looked at, that status. Oops. Status reason is just a coded or textual reason as to why it's in that status. So you might say cancelled and then provide a reason, child was too upset to take blood, or whatever the reason for that status is. Business status is where we're free to put whatever statuses we like. So collected, in lab, arrived, scheduled, whatever. I think we need to work through what they will be. Intent, the intent for the task, is it proposed, is it planned, is it ordered, is it an original order, reflex order, fill order? So I think we're gonna have to work through that, but I think the vanilla case is order, but perhaps we will use these if we're gonna cover reflex orders. Priority, how urgent is this task? Fairly straightforward. Code, this is a little odd, I find, because the code, if you look at the example codes, it's a code for the task. I clicked on the wrong thing. You have these set of codes. So approved, fulfill, abort, replace, change, suspend, resume. These are only examples. I find them a little odd. I kind of assumed code would be, this is an Australian eRequesting fulfillment task, some sort of code to represent that. So anyway, there's a code on task. Description, you can do human description. You could describe what this task is about for humans. Focus, we had set this to the service request because this task is about the focus of doing the service request. For beneficiary of the task, we had in the past set that to patient. The task is for the patient, they benefit. I kind of thought maybe it might be the practitioner, but later on we have requester, so I think that's clearly practitioner. Encounter, so if there's some broader encounter, you could fire encounter, you could pin that to the task to say this is part of that encounter. Execution period, when is the task to start and end? Authored on, when was the task created? Last modified, when was it last modified? Requester, probably going to be the practitioner role in our case, the doctor that requested the service request. Performer type, this is where you can, there's a big long list, but this is where you might say the performer type is radiology or pathology, or you can be trying to categorize tasks to say this is this is the class of consumer of the task. Owner, this is where we pin, you own the task, like this task service request has been assigned to Sonic Healthcare or Helios or whoever. So the owner would be set as, say, an organization to who's going to do the task. And as we say, it might be empty in the non-allocated scenario. Location, where the task may occur. Not sure if it's relevant to us, but it's there. Reason code, why is the task needed? I will highlight that reason code, reference reason are also on the service request. So we need to make decisions about what, do we put a reason code here to say why we're doing the task, or do we put that on the service request, or do we put it on both and make them align, or are they different? It's hard to know. Insurance, I don't think we're necessarily going to use it, but probably a very American thing. You can put a coverage or a claim about the task. Note, comments are made about the task, so anything you want to write on it. Relevant history, key events, history of the task. Again, service request has lots of history, clinical history stuff. This is provenance, so this is more who created the task. Restrictions, how many repetitions of this task, what periods can the task be done, and recipients of, I assume, this instance, who fulfills this, for whom fulfillment is sought. Input, so you can provide codes, other resources like anything as input, just other input you need for the task. And finally, output, which is when the task is completed, stuff it has created for us. I clearly see diagnostic report eventually arriving here to say the output of the task was this diagnostic report, a reference to it. That was a bit quick, but we've run out of time, but I'm glad we got through task as well. So is there any closing questions? If not, I think from here in the next couple of weeks, probably in the TDG, we're going to do this sort of run through service requests. And in time, I think we're going to go, we have to start deciding, starting from the start, identifier. Are we going to use it? Are we going to set it? What do we set it? And start walking through. And that's where we start building our profiles for file. And we make decisions and vote about, yes, we are going to use group identifier and we are going to put the barcode there. And this is how we're going to do it. So that's coming in the future. And we need to have more deeper conversations about these workflows and start, drawing in on a target workflow that we think. But I'd like to think we say somewhat 80% within at least one of these workflows, or stay, evolve from it, not just invent something completely new. So I think I'll finish there. Thank you everyone for coming. Sorry I was a little bit long. And we'll see you at the TDG meeting. And I think there's one this week, isn't there? Thank you, everyone.
Thanks, Angus.
Thank you.
Much appreciated.
Good on you.
Thank you. Bye.
Well done, mate.
Hey, I'm going to read through the comments.
Yeah, that's the problem with these. They get lost.
Yeah, you get
I'm
lost
doing
as soon as you close it, they're gone. Yeah.
I'm doing the same.
They should be stored in the meeting stuff on Zoom, I think.
I think you're right, but it's more the tedium of getting them where they're right here.
True. Good job. That was good.
Thank you. When is our next meeting? We have one this week, don't we? Stop sharing.
You're not sharing.
No.
Stop recording, maybe.
Oh, yeah. That's
Oh, yeah.
How do I do that? More. Pause. Stop.